All right, so we learned before how to actually look at an inequality in two equations and graph it. So we talked about this general idea. There's a linear inequality in two variables, x and y. It should look something like this. We did a couple of examples on this page, one with a vertical line and then one with just one in slope-intercept form. You could also do that for something in standard form, just got to put it in slope-intercept form like before. I want to go the other way and see if we can write linear inequalities given a graph. Instead of me trying to use my artistic skills right now, which aren't supreme, I'm just going to use Alex for an example. So this one says, and this is part of one of the homework assignments, write an inequality for this graph. It's an inequality. I know that because there is shading. If it was just an equation, there would be no shading. It would just be a line. Plus, I see that this line is dotted, which kind of tells me something also. So first, for this example, the first thing I need to do is write the equation of this line first. So y is equal to, and since this is a straight line, I could use slope-intercept form. That's mx plus b. So I know I'm going to have a y. I know I'm going to have an x. I just need to find the slope. Well, if I go here, I would have to go up 1, 2, 3, 4, 5, 6, 7, 8. So up 8. And then over 2. I think that's right there. Yep, 1, 2. So up 8 over 2. And then my y-intercept is actually at plus 5. So I'm going to do plus 5. Now, I can simplify this, so let me rewrite that. Y is equal to 8 over 2 is 4x plus 5. So if I were to find the equation of this line, it's y equals 4x plus 5. This is not new. We did this in the last unit. Now I'm looking at this and I've already established that this is an inequality, so I need a less than or equal to, that kind of thing. Now this line is dotted, so whatever it is going to be equal to 4x plus 5. I just need to know if this represents all the solutions that are greater than this line, or this represents the solution that are less than this line. By looking at that, because of the way it's drawn, I'm thinking that it is less than. All of my y's are less than the line. But the way that you should go about that is to test it when you're done. So make your best guess based on what it looks like. And it kind of makes sense to me that all of my solutions are on the bottom of this line if I consider this the top. But let me just test it. I just need to choose any point in this area. And if it is indeed true, then I made a correct selection here. I always like to use the test point 0, 0, so I'm going to use 0, 0. So 0, if I use this right here, I'll have a 0 less than or equal to 4 times 0 plus 5. I'm just using a test point to see if my solution or my equation, my inequality is correct. I'm using this test point 0, 0. 0 is less than or equal to 0 plus 5, so that 0 is less than or equal to 5. That is true. That means my test point is in the solution, which means that this thing is indeed correct. That is the equation of this, the inequality for this graph right here. All right, let me see what else we have on here. Maybe I can write it using, there's some information right there. We'll see if I have time for this. If I get cut off, I'll do it in another one. It says that Elsa's final exam has the true-false questions. They're worth 4 points each and multiple choice worth 5. Okay, so right away, I need to establish something. If I let x be, and in fact, I think it tells us right here, let x be the number of true-false, so true, false, y be the multiple choice. Now, she gets 4 points for each true false and 5 points for each multiple choice, but she needs at least a 93. So whatever the number of true false, she's going to get 4 points for that. Plus whatever the number of multiple choice, she's getting 5 points for that. She needs this total to be greater than or equal to 93, because it says she needs at least 93 points. So she needs to have this as an inequality. That is an inequality. It happens to be in standard form, but that's okay. All right, so if we were to plug that in, it would work. I won't have enough time. I'm going to expire here in 5 seconds. But that's how you can write the inequality, the